We use it every day for things like cleaning, washing, showering, and of course, drinking. But do you ever stop to think about how clean, safe water makes it to your home? If you're like me, you haven't given it much thought. But given it's the most vital resource that the city provides, it's not a bad idea to be familiar with the process. When the city decided to relocate its water facility in 2003, selecting a site near the Iowa River was key. By being located in the nook of the river, the city was able to develop 5 sources of raw water. The plant can draw from the river, a sand pit, an alluvial aquifer, and then 2 deep wells, the Solarian and Jordan aquifers. The city can use a combination of any of those sources, but one is the most effective for creating clean, raw water.
Our primary source here is the alluvial aquifer. We use our collector wells to obtain that water.
The groundwater collected by this well is mostly from the Iowa River. So how is it different?
The sand and gravel in the alluvial aquifer acts as a natural filter. And so the water that comes into the plant, our raw water, is really already filtered by the sand and gravel in the alluvial aquifer.
It sounds strange, but Craig explained that the sand and gravel actually clean the water as it makes its way from the river to the well.
Turbidity, the dirt and particles in the water are removed, and organics that cause taste and odor are also removed.
I'm likely not alone here, but turbidity is not a part of my daily vocabulary. Simply put, it is the cloudiness or haziness of a fluid caused by a large number of individual particles. It's generally pretty hard to see, but is easily tested for. This is measured by nephelometric turbidity units, or NTUs. The measurement of turbidity is a key test for water quality. To display the difference, we decided to draw samples from both the river and the alluvial aquifer.
So the difference between the river, which is changeable and can go up to hundreds of NTUs, and our consistent source of collector well water, which is always right around 0.1 or under. So that's kind of what we want to show today.
Once removed from its muddy banks, the Iowa River is actually surprisingly clear, but obviously not safe to drink.
So this is our sample of river water that we just pulled out from the river. It's a turbidity of probably 15 or 20 NTU, which is nephelometric turbidity units. Our finished water generally is 0.05 in that range.
The alluvial aquifer that we have been discussing is literally only about 100 yards up the road from the river.
So we're going to compare this to the river sample we grabbed earlier, see if we can detect visually any difference in turbidity. Turbidity is pretty hard to pick up by the human eye, but we may be able to see a little bit of difference here.
As Kevin draws his sample, you already noticed the difference.
The sample on your left is the river sample that we collected, and the sample on your right is the sample that we just collected from our collector well.
It's not drastic, but certainly the sample from the well is more clear. And that beginning product can make a big difference when purifying water.
The alluvial aquifer creates a raw water, a really high quality raw water, low in turbidity and low in organics.
Given the importance of these wells, the city took extra precautions after the 2008 flood, raising all electrical equipment high off the ground and installing flood doors to keep water out.
They were projecting the highest that we would ever really need to worry about is about 4 feet. If it even got close to that, this door splits in half so we could boat up and have access to get inside to check our equipment for just going through this top portion of the door.
This ensures that Kevin and his team can draw from any combination of these sources, even during flood events. Even though the raw product has less turbidity, it still has bacteria and other imperfections that need to be removed. The city's state-of-the-art purification process includes 6 steps. First, the aerator removes gases such as CO2 and ammonia. From there, the water goes to the softening phase, where lime is added to remove calcium.
We take out about 2/3 of the hardness out in this process.
Next, the water moves to the recarbonation tanks to remove the remaining hardness and lower pH levels. The water then moves to the granular active carbon filters, which removes all remaining organics.
It does a really great job of creating a barrier between the river and our customers.
For the next 3 to 4 hours, the water is mixed in the chlorine contact tanks.
So we get a really good, high quality level of disinfection in the water.
The now clean, safe to drink water is kept in storage tanks until it is sent out to the city using high pressure pumps. It's a complex process, but with 75,000 people counting on your performance each day, the staff here is committed to exact precision.